Hello, I hope we are live. Hello, everyone. Welcome to this live stream. We are going to wait for a couple people for a couple more minutes. In the meantime, you can write us in the chat where you are joining us from. Where are you based right now? And maybe what are you working on right now? Let us know how is it going. I have this very weird background with me. There is this small bug. Hopefully, it will disappear soon. And I'm checking the stream right now. It seems like there are no problems. Nice. I can make a small introduction right now then. Hello, everybody, again. Today we have Gilad with us. Welcome, Gilad, by the way. Gilad is a data scientist and AI engineer with more than 10 years of experience in applying cutting-edge machine learning and AI techniques. And together with Gilad, today we are going to talk about modular RAG systems and how to make them like we are building Legos. I am quite excited for this. And Gilad, if you are ready, we can already start, right?
Yeah, great. Thank you.
All right, then the stage is yours, and I will take myself off the stage.
Great. And can you see the screen now, the PowerPoint? Now I can't hear you. Okay, I'll take that as a yes. You know what, just to be sure, can you just say something so I know everything's okay?
We can see everything.
Okay, great. Okay, welcome everyone. I'm excited to be here and thank you, Bilge and the people from Haystack for hosting this. It's a really nice project that I enjoyed working on, and it also it's a way for me also to demonstrate a new tool that I built called Hypster, and we'll go over it in this session. So a little bit about me. I'm an independent AI consultant. I have 10 more years of hands-on experience in data science and AI. And really, after a lot of years of working with in this field, I had this yearning to really share my knowledge more and put the time into the things that feel important to me. So this is one of those things that we're cooking up for many years, and now I have finally the chance to actually build it and to share it with others. I'm naturally curious about how things ought to be done. This is something that drives me, even in small things like how to make good coffee, larger things like emotional work, and also data science and AI. And today we're going to talk about modular RAG, a bit of a background, just for in case someone here is not 100% sure what RAG is, a bit of a motivation for why to build modular RAG systems, and in general, modular AI systems. A bit of the challenges today and how I suggest to solve these challenges. And then we'll have a live demo and Q&A session. So just one slide to remind people or to make sure we're on the same page with regards to RAG, Retrieval Augmented Generation. This is a very simple graph showing how this process works. It's a simplified RAG system. We can have a query, a user query, and instead of just putting it into the LLM and asking for an answer, we ingest, where we index documents that are relevant to the questions that our users want to ask. And with the query, we try to retrieve the most relevant documents to this query and then feed into the LLM both the query and the documents retrieved to get a final output. Today our motivation is to build these RAG pipelines that are optimal with regards to our performance metrics. And it can be accuracy or recall precision, etc., user satisfaction. And it can also be about the cost and latency. We also want to make sure that these systems are extensible. We can extend them, and in that sense, they're future-proof. So if tomorrow there's a new model or new data is coming in, or we get feedback from our users that something is missing or something might need some adjustments, we want to have a system that is extensible and that is modifiable and in an easy and intuitive way. And finally, we want to do it while having a smooth developer experience and using good coding practices. And this enables the first points, because otherwise we are stuck with a brittle and rigid code base, which is never a good idea. So the first pain point that I want to mention here, and I experienced this for sure, and I'm sure many of us experience it when we want to get started with RAG systems, and it's the complexity overwhelm. So a working RAG solution usually requires multiple moving parts, and there are so many new implementations, articles, tricks that come out every day. And it seems like it's really difficult to navigate and to get started in this space. So I think what can really help is a guide, a map, a unified language that we can use to describe different solutions. And for me, a turning point was when I found this paper, Modular RAG, Transforming RAG Systems into LEGO-like Reconfigurable Frameworks. And really, when I read it, it was a pivotal moment, because up to that point, it felt like every new solution was something completely new. And after reading this paper, I realized there is a way to express existing solutions and potentially new solutions with the same building blocks. So this is the most important slide or kind of figure from this article, from this paper. And what it does, it takes the concept of RAG or RAG pipelines, and it breaks it down into 6 different parts, components. Indexing for indexing documents relevant for the retrieval process, pre-retrieval for taking in the query of the user, transforming it, expanding it, constructing it into SQL or whatever is needed, retrieving the actual documents or potential documents, post-retrieval for usually re-ranking, filtering, compressing the return results, and then finally generation, putting the data into an LLM and then verifying that the output is relevant and fit for the question, for the prompt. And then at the bottom, we have orchestrations. These are like operators that we can use to connect and to create workflows, to connect components and to create workflows. So we have routing, we have scheduling, knowledge guide. These are different types of ways we can control the flow of information of the different steps within the RAG pipeline. And so a big insight here is that if we have access to these core components and operators, and we can select the ones that we care about, define them, their hyperparameters, and connect them together, then we can build endlessly complex pipelines. And in the article, we see examples, many examples of kind of different techniques for RAG and how you can express them with these basic building blocks. So Flare, this is an example for Flare. I think it's forward, look ahead, something. Yeah, I don't remember the exact acronym, but then it's just expressed within these components. And you can see many examples of that. Okay, so that's the first pain point we talked about, is the complexity overwhelm. And the second pain point is Well, how do you select, define, and connect components in a dynamic way? Not in a static, rigid, hard-coded way. That's pretty straightforward. And how can one code base contain multiple competing pipelines? And even how can you perform sweeps? That's like in the lingo of hyperparameter optimization, to sweep across different configurations and test different pipelines automatically to choose the one that's optimal for your use case. And I don't believe, from my experience, I don't believe that there was a good answer to these questions. There were answers, but they were lacking in different aspects. And I actually just wrote an article about the difficulties in doing all these things. I can link it at the end of the show. But for now, we'll just explore how this pain point can be solved using Haystack and Hypster within the context of RAG pipelines. Okay. So Haystack, I'm sure most of you know what Haystack is, but just in case, I'll go over the main points of this framework. It's an open source framework for building production-ready LLM applications. It has built in a plethora of components and operators. It has a powerful pipeline API. From my understanding, this was a big refactoring of the package of the framework into 2.0. And we will go over this pipeline API, and this will be really the core of how we use this framework. In my personal opinion, I think it's designed really beautifully. I think it's a very minimal layer of abstraction on top of the components or generators, embedders, etc. And this is really important for me, at least when I work. I can really see very simply what each component does. I can edit it, customize it, create new ones pretty easily. And the documentation is really accessible, which is really important to navigate in this space. And just now they announced the new Studio UI, which is exciting. I haven't checked it out, but I'm excited for that. And Hypster, it's an open source framework that I built recently, actually, and it's for defining configuration functions to build optimized machine learning and AI workflows. It's fully Pythonic, which is important, and we'll see this very soon. It doesn't use any YAML, JSON, or any external languages. It's modular, so it supports nested and swappable configurations. And it's also 100% meant to be intuitive as possible. The syntax is very compact. It's dry in the sense that don't repeat yourself. You don't need to have any extra wordings or syntax within the framework. And it also has an interactive UI, because I personally believe that the way to work with different configurations is not through the command line. It's not through memorizing different values. It's actually through a modern UI that you can see the relevant configurations that are available. So today we're going to go over 5 levels of modular RAG. The first one is just a hard-coded RAG pipeline. It's not modular. And then we're going to add dynamic hyperparameters. And then we're going to add different components that we can just swap them with one another. This is the swapping part. And then we're going to use nested configurations, which is more like a hierarchy of configurations. And then finally, if we have time, we will go over the full code for modular RAG from the article that I posted on Medium. Okay, so now we're going to go over to the live demo. And if there are any questions so far, please let me know. Oh, and by the way, there's a new documentation site for Hypster. So if you're curious, you can check it out. Okay. Great. So this is a very basic RAG pipeline. This is taken from the tutorial section of Haystack's website. I changed it a little bit, just the ordering, but it's the same essential thing. So what we have here is the indexing pipeline. We can choose a document store. This one is in memory. We can choose an embedder, which uses this, in this case, sentence transformers. Within it, we can define the name of the model, batch size. And I already put here a hint. This is like a gesture for those who use these comments when they work. And I used to do this all the time. This is like a spoiler for what's coming next. When we have hard-coded pipelines, or when we build single pipelines in this way, we sometimes want to remember what we tried, or we want to remember, have like accessible all the possible values. So we usually, or I usually used to use comments for that. So if I want to change it, I just kind of like replace it here. And then maybe some of you already know where this is going, okay? Okay, so I'm just gonna continue. So we define a document embedder, and then we build our indexing pipeline. This is the pipeline API I talked about. You add components and then you connect them together. So we have the document embedder, the document writer, we connect them together, and that's about it. We need to make sure that the same embedder we use for the documents is also for the query. So we initialize this one, same sentence transformers, just for texts, for single text, with the same model. And here, since I changed this, maybe it's a good idea to make sure it's the same. A retriever, this is a generic embedding retriever, and then an LLM with a template, a prompt template. And then we add the components, we connect them together. We can run this and see, we can visualize it using the show command here to see the indexing pipeline, and then also to see the RAG pipeline that we just built. And then we can just select our data set and run the indexing part, ask a question with the RAG pipeline, get a response, and we're good to go. And this looks relatively straightforward. And even if even if I added many different parts here, like creating a really, really complex pipeline here, I still think that there is a fundamental problem with building in this way. And this is like hard-coded way. And the reason is that it's hard to kind of accumulate and gain knowledge along the way. Because whenever I try something new, I kind of need to, in some way, erase what I did earlier. And this takes us into a world of bad coding practices and creating a brittle code base, essentially, which is hard to maintain over time, hard to extend and optimize. And so now we're going to move into a different way of coding. And this applies not only to RAG systems, it applies to any machine learning and generative AI and perhaps even other fields where we can build a code that can contain multiple pipelines, multiple options simultaneously. So before we dig into that, I just want to give you a really short introduction into Hypster. And this is a minimal example of Hypster. This is how it works. So we first import from Hypster two things. the hyperparameter HP, and the config. Config is the decorator for the function that we're going to use, the configuration function that we're going to build. We can give it any name that we want. And then the only thing we need to put here is this hyperparameter HP of type HP. This is very, very similar to Optuna. If you've ever worked with Optuna, where you need to put the trial as in the signature. This was highly inspired by Optuna, and actually there is going to be an integration with Optuna in Hypster. Currently there isn't. And once we have this set up, what we can do is we can define different variables with different hyperparameters. So the syntax is HP dot, and then we choose what type of hyperparameters we want to use. So select enables you to select an option from a list, and this can be simple types like strings and ints and floats and booleans, but it can also be more complex ones. And you can use either a list or a dictionary. So within a list, you just put the options, you can choose a default value, and you're good to go. What this means is that within this function, var doesn't have a value, it's a potential for a value. And the values can be one of these three, or even something outside of it. If you want it to be only these three, then you can just put options only. And then we can have another select hyperparameter. And here we can define strings as keys, and then the values can be arbitrary. They can be a class instantiation. They can be numeric or whatever we want to put here. And here what's nice about Hypster and the fact that it's fully Pythonic is that we can define conditional configuration spaces. So in this case, we have this conditional if var equals a, then, and not only we can define things here, we can also define hyperparameters here with different ranges and values. So here var 3 and 4, one is int, the other is boolean. Here is the default value as well as here. You can optionally define minimum and maximum values for int and numerics. Numerics can be either int or a float. And here we've configured, and we have number and text. And we also have a variation for each of those, multi. So multi-select, multi-bool, multi-int, etc. allows you to define a list of these values. So after we've defined our configuration function, we have what I call a superposition of pipelines or of whatever you're building. There isn't a specific pipeline or configuration here. It's a potential for a configuration, a specific one. And the way to instantiate it is by calling this function. And when we call it, we can use several arguments. One is final vars, variables. And here we can just say, hey, when you run this, return only the first variable, var. I can put all of them. I can use also exclude vars. So I can say return everything except for var2. And here the values we can define, we can instantiate specific values for specific hyperparameters. So here I selected B for var. And now when I run this, it just returns a dictionary results. And this dictionary has only var. If I remove this, you will see everything except for var2. And also here you can notice, because I chose var to be B, then it goes within this conditional into this statement, and it only returns var 5 and 6 without 3 and 4. Pretty simple, pretty straightforward. And here we already can go into our interactive UI, and I think this is a nicer way to use it. We can interactively see our conditional configurations. So here I chose var to be b, and then I can see that I have a number that's float and a text. I can change it. And once I change it, I can just look at the results, and it's just, it's updated. One second. Oh, interesting. It didn't update the text. Never demo live. Okay. Interesting. I'll take a look at that. I do need to say that the interactive UI is not fully tested yet. The rest of the package has more tests. Okay, and here I choose var to be a, and you can already see that it shows var 3 and 4 according to their definition within the configuration space. Okay, I hope this was clear, and now we're ready to move into putting this into a modular RAG system. If there are any questions, please put them in the comment section or the Q&A. Okay, now back to our basic RAG pipeline. We have pretty much the same code as before, but here what we do is we define different model types, different options for the models. It doesn't need to be a comment. We don't need to save it somewhere else. This should be in the code. And this can actually even be generated on the fly. And I'll show you an example in level 5, I think. So here we define the different model types, and we have an embedding model here. We use select with this list of models. We can define a default value. And here, the document embedder can use this selected value. And you can also define on the fly hyperparameters. So batch size equals HP int, default 16, and this is the range. We can do the same for other variables, defining the model here, and this is on the fly, select, etc. And also here, notice something. This is something technical, but Hypster automatically creates names for different hyperparameters. So this, you can even guess, this hyperparameter is called emb model. It's pretty straightforward. There is no reason to add this. You can do it, but you don't have to, because Hypster automatically analyzes the code and tries to infer the most sensible name. It can also do it in a nested way. So here we have doc embedder, and we have a class in initialization, and within it we have batch size. So this will be called doc embedder dot batch size. And if I want to change this, I can just say batch size. That's okay. But I don't have to. So same goes here. Generator quargs, and then temperature. But this can get pretty long, so I can override it with just temperature. I can just select to do that. Okay, so the rest of the code is the same, and we have this configuration function. And now we can run this regular, like manually with defining the values. But we can also use the interactive UI. Let's just make it dark theme. Okay. So as I said, I can see the different options here. I can change the batch size, generator models, and as I do this, the results change. So in this way, and we're already starting to get into this modular RAG territory, where I don't know necessarily in advance when I build this code, what are the optimal hyperparameters with regards to my problem, my business use case, my specific data. I don't have to really care so much about it when I write the code. I just need to make sure I have the relevant options here. And when I have it, I can just instantiate it and test different configurations, either manually or automatically. And here, if I run the code, it just creates this, like different indexing pipelines and RAG pipelines. Okay, great. So I hope everyone's with me so far. Now we're going to make it a little bit more complicated, just a little bit. So far, we took the same components and we added some hyperparameters. But what if we want to define a hyperparameter that says use this component instead of that component? So in this example, we have very similar code, but here we want to select whether we want to use sentence transformers as embeddings for our documents and query, or we want to use fast embed using sparse embeddings. We can also use both, but in this example, it's if this or that. So what we can do is very simply define this embedding type, put these two options or more, and then just say if embedding type equals sentence transformers, then you can import what you need and define these components here. Otherwise, if it's sparse embeddings, we can define these here. And just a nice trick that we can use, the models that we can use for fast embed sparse text embeddings, we can get this from this code here, list supported models. So even if tomorrow they add another sparse text embedding, this will be updated on the fly because this code runs whenever we select instantiate it, whether interactively or manually. And there are a couple, when we use the Python API, it's not always smooth sailing if we have different components, because different components can have different names for inputs and outputs. So we need to make sure we wire them properly. So the sparse embedders, instead of expecting embeddings as inputs, they expect, or outputs, they expect sparse embeddings. So we have this string here that we're going to use when we create the pipeline. You don't have to fully understand it on the fly. It's not super complicated, but the point is that you can just play with it. You can define it in whatever way you think is relevant. Hopefully, it doesn't turn into a big mess. This is like the ideal, that it's readable, it's compact, and you have control over this. And in my personal opinion, if you run this and then you see, oh, okay, so sentence transformers works better than the sparse ones in terms of speed, I don't know, performance, or a combination of those, I don't think you necessarily need to delete this. Because maybe you want to combine them, or maybe tomorrow you will have a new model or a new retriever that actually the second option works better. And this is, of course, it's dependent on your use case. But in this way, we accumulate knowledge, and our experiments can be recombined with other components in very different ways. So again, we have the same thing here, and you can see if I select sentence transformers, I see the relevant hyperparameters. If I select fast embed, then we have different ones. And I can just run this. It works. We're all good. Okay, moving on to the next one. Now, some of you might have thought, well, I don't really like this big if clause with all these like definitions here. It feels like it's a little bit too long or verbose for one function here. And that's right, actually. And we have a better way to do this. And this is nested configurations. So what we can do, we can have a separate configuration function for sentence transformers and one for fast embed. And here we can define all of its logic and whatever we want. This can be really long, or this can also have sub or nested configurations. Once we configure this, we save it as a module, as a Python module using the save function here. And this is a working portable solution that we can use in other projects or other parts of our project, or we could even use it multiple times if we have, for example, two separate parallel pipelines that we want to work with. So we don't have to rewrite this whole thing. We just define this configuration. We save it to disk, and then we can reuse it. Same thing for fast embed. Great. Imagine a use case where you have time-sensitive users or situations where latency is really important. So maybe you want to utilize this fast embed sparse embeddings because they're faster. And then you can have these two options not competing against each other, but actually provide solutions for different use cases. And now we go back to the main pipeline, the configuration. And what we do here is very simple. We just select the same thing here, the embedding type, fast embed versus sentence transformers. And then we use the nest hyperparameter call. And nest means nested configurations. I just give it the path to the configuration functions file or module. And then what it does, it propagates the values. So if here I say results equal rag config values equals, here I do embedding, dot model, then it goes in and say I chose the sentence transformers. So it goes into this. I should use emb model. It defines this value and propagates this value into this configuration. And this way I can see, in this way, I can control all of my different configurations. I can have 5 different levels of nesting here. Okay? I can control all of these with one main configuration function. And this is really, really important, really crucial point, because sometimes when, maybe most times when projects become very complicated and complex and they have different moving parts, knowing that you have one kind of main configuration function that can call upon, utilize, propagate values into nested configurations, this is really important, really key for handling this complexity in a really nice way. The alternative, what I used to do was work with YAML files, and they just used to get so big and out of control that only I knew how to navigate between them and what are the different kind of like conditional dependencies they had. And in this case, you don't have to remember anything. You can just go into the, again, I recommend using the interactive configuration. And here you can just choose what you want, sentence transformers. And it really shows here nicely, it kind of shows a sub-module here, embedding here. And whatever is relevant here, you can just choose, change it. And then let's say you want to choose fast embed, it just shows whatever is relevant here. And again, running the indexing pipeline is the same thing as before. You can just see the results that come out of here, sparse embedding, etc. So now I prefer to pause and see if there are any questions before we move into the more elaborate example for modular RAG, the full one. Yeah.
Yeah, thank you for all the information so far. Actually, we have some questions from the audience. So the first one is, so the purpose of using Hypster is more so the prototyping phase of development. I noticed this has a UI and it's shown in Jupyter notebooks.
Yeah, it's a good question. So in some sense, yes. In some sense, no. Or I guess you can say both. If the way you use it is to find the optimal configuration for your project, and you use it manually or interactively, and then once you find your optimal configurations, you just kind of like instantiate this this pipeline and you ship it to production, then it's mostly relevant in the development process. However, if you you can do more than that. A couple of examples can be, you can have you can deploy this. You can deploy to production, and I'm not saying you. I'm not suggesting you should do it tomorrow because types need to be tested more vigorously to perform under production settings. But if someone is interested in that, please let me know and we'll work on it. And I believe it is possible. I don't see any setback to that. Just kind of trial and error with the package. So you can deploy this thing or this actual code that's written here, the configuration and the code here. And then what you can do, you can have this kind of super pipeline in production. And then you can do A/B testing. Very simply, you don't have to deploy two different pipelines. You can just deploy this one, and then every user can just get a different instantiation of the pipeline. It's instant. The instantiation is instant. So you can work with it like this. So it doesn't have to be interactive, manual, etc. And another use case can be, you can have an agent that uses this configuration function as a tool, and you can tell it which values it expects. And then an agent can, let's say, based on the query, can instantiate a full RAG pipeline and give an answer to the question. So both.
Yeah, so basically I can use this example to create a pipeline builder tool to give to my agent, and my agent can decide on the parameters, these, as you showed in the selecting components in hyperparameters notebooks here. It can just design the pipeline itself and then run it maybe. Yeah, good point. And more like a follow-up question to that one. How is this applied in code bases with only like Python files? Because you're showing the Jupyter notebooks, but can we also do the same thing in Python files?
Yeah, so the only difference is that as I showed, you can just instantiate these in this way using the values keywords here in the function. and this will work fine. Yeah, there is no problem with that.
All right.
Maybe I misunderstood the question, but it can work with only Python files. It's just a bonus. Like the interactive UI is a bonus. I work with notebooks. I find it interesting and like interactive and helps me iterate faster. But you don't have to use it.
All right, thank you. I see that the questions is also answered for them. So we can jump into the last notebook that you're going to show, Gilad, and then keep the questions coming in the comments. Then I will take myself off the stage again. All right.
Okay, great. So now we're going to go over the modular RAG pipeline that I posted on my Medium blog post. And it's more elaborate, it's more complex than the ones I showed so far. For me, it's just to demonstrate different ways you can work with this setup. I'm not saying this is the best way to build a RAG pipeline, and that's the whole point of building a modular RAG pipeline. You can just add different components that you think are relevant for your specific problem, and then just play with it and experiment and see what effect each component has. You can mix and match. So this is a kind of a summary in some sense of what we're building here. This is like the most complete pipeline we can build. This is the indexing pipeline. Takes a PDF, creates a summary of the first couple of pages, and then splits the text, the PDF, into chunks with the summary propagated into them. It doesn't have to perform this LLM summary on each chunk. It just takes the first page or two and then adds it to each chunk metadata, embeds the chunks, and then puts them all in the document store. And then upon retrieval, you take a query, you embed it, choose either only use only use embeddings or also use BM25, join them together, the documents retrieved, use a re-ranker, and then put the final documents into the LLM with a query. So we start actually with the LLM configurations because we're going to use it in many different places. And you can already kind of, when you work with Hypster, you can already start to get a sense of different tricks that you can use. Here, I put the Anthropic models in one dictionary. I like to have shorter names and OpenAI models, and then general model options are kind of both of them. And then you select from these options. You can define the temperature for the LLM. And then you can just ask if this is one of the OpenAI models, then you can just instantiate a OpenAI generator. Otherwise, use Anthropic. And what's nice about these conditional imports is that if you don't have it in your environment, you won't get an error unless you choose the OpenAI models. Okay, so that's an LLM. We can just play with it here. That's great. And now we're building the indexing function. And here the first question is, do we want to enrich our documents with LLM summary? And this opens like a conditional here. If enrich document with LLM, then we have a whole section that calls the LLM from before. We have a prompt, summarize the document's main topic in one sentence, and we just give it the first 1,000 characters of the PDF, of the whole PDF. And then I just added a custom component called add LLM metadata. And then it just kind of wires this indexing pipeline to run this LLM query on the first 1,000 characters and add it to the metadata. And then finally, we can choose how to split our documents, our PDF, whether by sentence, word, passage, page, the overlap, the length. And then we finally have this configuration. And as you can see, we have a nested configuration for an LLM. If I do false, it doesn't show the LLM part. And yeah, I'll just kind of skim over this. You can see the full code on GitHub. And this is using fast embed for embeddings. And here I can just show you a small example why it's so important to use Python for these configuration functions. I don't know how you can do it otherwise. In this example, it's a kind of an edge case, but I think in every project there are at least one or more edge cases like this. So in quadrant or document store or vector store, you need to define manually the dimension of the embeddings that you're using. And so whatever model we choose has a different embedding size or dimensions. And here we need to get the model dimension, like the embedding dimension, using this function from fastembed. And we're going to use it later when we instantiate the Qdrant vector store. And my point here is not to talk about all of this. It's just to show you why configurations need to be, in many cases, Pythonic and allow for these kind of more advanced use of code and not just have a YAML file that defines strings or numbers, etc. So we do the same for Gina embeddings. I wanted to show how to use an API and also, or using a kind of a local embeddings. And then for the retrieval, we use an embedding as default, and then we ask whether we should use BM25 as well. If we do want to use it, then we add the BM25 components, and we add also a document joiner that joins documents from embedding retrieval and BM25. We can define the weights here. This is also like a nice trick. The weights can be BM25 weight minus, like 1 minus this one to come to 100% together, and we route them together. So here we can, every time we build a configuration function, it's independent. We can just see it here, and then we can just define whatever we want, make sure it works. And here, this is what I told you about Qdrant retrieval. It expects to get here the embedding dimension. So we're using this kind of the data from earlier to input it into this configuration function. And finally, yeah, we have the re-ranker here. Same trick as before with defining a dictionary, if then else, a response configuration, and finally the main RAG configuration. And I didn't say it explicitly so far, but what's nice about the pipeline API is that you can kind of like build it as you go. It's really, really nice. And so here we're building the indexing pipeline, and then we're adding components to this existing indexing pipeline. We're selecting the embedding type, the document store, and here we're passing the embedding dimensions into the document store if it's Qdrant. And then finally, yeah, just connecting the different wirings of the pipeline together. This part doesn't do so much. We can decide whether to use a re-ranker or not to use a re-ranker. And this is very much in the spirit of modular RAG. We don't know exactly how this RAG will look like eventually, but we can have this configuration space here with all the different hyperparameters and components. And just by this, just like defining whether to use the indexing in this way or another, whether to use, this, oh, yeah, okay. Yeah, I think, yeah, okay. So yeah, we can define the different document stores, and automatically we get these to match using a re-ranker or not. So this is a very modular, very flexible way of defining a RAG pipeline. And as I said, there is a way to sweep through different configurations and test them simultaneously. And also, the next big task in Hypster is to include Optuna as a smart hyperparameter optimization framework to intelligently search through promising solutions within this search space. And again, finally, we can run whatever. I will check this error later. But this worked just before, and then we can run this indexing pipeline, and the query, it returns a good answer for the questions. The PDF here is of modular RAG, and I asked it, what are the 6 main modules? So indexing, pre-retrieval, retrieval, post-retrieval, generation, and orchestration. Yeah, so I think that's it for now. And we're good to go over to the questions and answers part.
Thank you. Thank you so much for the great tips and for all the examples that you showed. I actually have a question. So I am wondering, what would be the best way of using these different pipelines to compare their performances? So how can I easily evaluate these different pipelines? Because I'm not going to, I want to run the same query with 2 different pipelines with different parameters, maybe with different components, and then see the results and somehow compare them. What would be the best way?
Yeah. So I do have a code that does this. It's just a slightly different project, but essentially, you should have one function or one piece of code that takes results. And with this results, you get a score or scores. And ideally, you have an experimentation framework like MLflow, weights and biases, where you can log the results. And then what you can do is, once you have these 2 things, like you have one function that takes the results, gets a score, and as it does this, it logs the selected configurations and the scores. And then what you can do, you can define a subspace that you want to search through. So if you want to search through all of the possible solutions, configurations here, which can be humongous, like really, really large, that might not be the best thing to do. Maybe you can define a stopping criteria, but you can define a subspace that you want. For example, you can say enrich doc with LLM equals true, and I want to have this kind of hard-coded in some sense. I don't want you to look for solutions that have false. So there is a way, and I can show it I don't have it ready here, but I can show
Mm-hmm.
a kind of pseudocode how to do this. And you can define, for example, I want you to look for the subspace, use reranker, true and false. And kind of consecutively, you can build this subspace that you want to search through, and then run a loop or kind of a parallel process that just instantiates it. It's essentially just giving a dictionary of values using this subspace, and then running this in a loop into the function, and you're good to go. In terms of like coding, it's not very complicated. The reason why I don't have it here is because I really want to do it using Optuna, because I find that the way that
Mm-hmm.
they sample hyperparameters and they also assume conditional space, because it's a conditional space, because it's not just like a list of hyperparameters, there are different types of conditions between them. I prefer to kind of implement it with that and then show a proper example. But if you're interested, I can send a snippet to how to do it. But this is the main idea.
Mm-hmm. Thank you for sharing the details. We don't have any more questions in the chat, and we are a bit over time. So if you like, we can close this session. And how can people reach out to you? Can you maybe like let us know? Do you use LinkedIn? Are you on Twitter?
Yeah, I don't use Twitter or X. I do use LinkedIn, and I post on Medium. Definitely, if you're curious about Hypster and building these modular systems, feel free to text me on LinkedIn or email. I am very curious how people react to this. If it resonates, if it sounds good, if you want to contribute to the project and add your inputs, that would be great. Yeah, I think that's about it.
Nice, thank you. And I've posted the repo of all of these notebooks.
Great.
So
Great.
if people interested, you can go there and check the notebooks yourself, maybe play with some of the components, some of the parameters there, test Hypster yourself. All right, that's it. And you will also see the recording on YouTube right after the session, so you can always go back and revisit. Thank you so much, Gilad, for all of this information and preparing all of these notebooks for us. See you soon. Have a great rest of your day, evening. Thanks, everyone, for joining.
Thank you. Thank you so much.
Bye.
Bye-bye.